and you have pudding too.
Yeah, vanilla.
Oh, chocolate. Oh, it's the best. After a day like today, I need some pudding.
Awesome. Dude, how's your day going?
Not too bad, not too bad. I'm trying to figure out how we're going to teach the next thing in science, though.
Yeah. How your students? Because, like, I got a couple. Like, man, that Blaze Eddington, he is awesome.
Really?
Yeah. Do you have him?
No, I don't, because you have him.
Weird. Gosh, that kid, like, totally chopped off his finger, and he's still here at school today. I mean,
wow.
just a hard worker.
That's awesome.
Yeah.
That's awesome. I'm glad he's still in school. Hey, you know what? Seafloor spreading is our next topic.
Mm-hmm.
And I'm thinking that we could use what we have right here to do a little demonstration.
Yeah?
What do you think?
Yeah, I could see that. Using some pudding and some wax paper to show kind of like the spreading kind of deal, right?
Well, yeah, we could use some wax paper and maybe some cardboard.
Okay.
So let's go find some of that. Okay, so we have our wax paper and we have our cardboard, which would be our plates. So let's start with some chocolate pudding. And seafloor spreading has to happen on a divergent boundary. So we're going to set them here. And see how it made a little ridge in the middle?
Mm-hmm.
Okay. So now do we see how the magma oozes out?
Mm-hmm.
Now let's try vanilla and see if we can get another layer. And as we pull it apart, we got some on that one, not so much on that one. Let me just try it again. There, that was better. Now we can see the layers. Let's try another chocolate.
It's almost like it's building mountains there in the middle.
You see getting thicker and thicker.
Mm-hmm.
Well, where does seafloor spreading happen?
Definitely along the Mid-Atlantic Ridge.
Yeah.
So we're adding another layer of vanilla. Oh no. Oh no.
Those are some big mountains you're building. I think it's really cool how they're striped. There's a brown layer and a yellow layer and a brown layer, and it smells delicious.
Did you know that in the middle of the Atlantic Ocean, there's a great big line that goes all the way through? It's a fault line where the plates are spreading in opposite directions. And when plates move apart, what's going to happen? The magma's going to move up, and that's exactly what happens. In fact, the bottom of our ocean is completely covered in a mountain range created by this Mid-Atlantic Ridge. So I want you to remember that when we talk about a divergent plate boundary, those are two plates that divide or move apart in opposite directions. So we see the oceanic crust beneath the ocean floor. We talked about how that's the most dense of all the layers of the crust. And underneath it, here you see the lithosphere, which the crust is part of the lithosphere, but underneath it what we can't see is the asthenosphere, and that's what's causing this to happen. So keep in mind that right here along the Mid-Atlantic Ridge, we've got magma coming up as lava, creating mountains, and these plates are moving apart in opposite directions. Later, we're going to talk about subduction and what happens to that plate. You might be asking yourself, why in the world is there a big crack in the center of the ocean? Well, we talked before about the lava lamp and the convection that happens when you have material that's heated and it becomes less dense and rises. The convection is happening in our mantle. So down here in the outer core, the bottom of the mantle is being heated, and that heat is going to come up and move, and it's less dense. And it's going to stay up there until it cools down and drops back down. And that happens in a circular pattern. What's happening is underneath the oceanic crust, you've got the currents moving up this way, and when they divide, they're pulling the plate apart. And it's leaving that crack all along the Mid-Atlantic Ridge, and it's leaving enough space so that all along it, the magma from the asthenosphere is going to seep up through that crack at that divergent plate boundary. We call this the ridge, and specifically in the middle of the Atlantic, we call it the Mid-Atlantic Ridge. So you have a plate moving that direction and a plate moving that direction. Eventually, those plates are going to run into other plates, and that's exactly what happens. When you have the oceanic crust hitting the continental crust, for instance, this would be the North American plate, it's going to be more dense, and so it's going to sink back down. That creates a trench. We talk a lot in class about movies, and if you've ever seen the movie Finding Nemo, they talk about, don't go to the trench. What happens is you've got continental crust, and then all of a sudden you meet that point where the subduction zone is happening, and it literally drops off into a trench. And we call this a deep sea trench, and those are at areas of subduction zones. So subduction is a verb for the process of when those plates are pushing beneath the other. And when you have two plates pushing, the more dense plate is always going to sink below. So again, this is the Mid-Atlantic Ridge. It's created by convection currents in the mantle that are going in opposite directions, pulling apart the crust, which is also part of the lithosphere, and creating these deep sea trenches. I hope that while you saw the lab today, you noticed what was happening and the mountain building that was happening and the fact that we were getting different stripes, because that's going to be really helpful as we do our activity today. Assignment tonight has to do with page 231 in your book. What we did was we pretty well followed the model that was in the book, but we used yogurt instead of pudding. We want you to look. This is kind of a heat sensor model of what's happening inside the ocean. So down here you're going to see South America, North America. This is Africa. And through the middle of the Atlantic, that deep red color is the Mid-Atlantic Ridge. And that is the spot where the magma is coming out. Now think about it. Where is the newest rock going to be formed? Is it going to be formed where the magma is coming out and cooling? Or out here closer to the continents? Well, of course, the newer rock is coming from the Mid-Atlantic Ridge, where the magma is coming out as lava and creating new rock. And as far as you can get away from it, that rock is going to be older. I want you to keep that in mind as you answer some questions. These questions are going to be on page 231, and it's questions 6, 7, 8, 9, and 10. So in your science journal, we want you to title it Skill Lab Model at the top of the page, and then answer these, 5 questions for class tomorrow. So, seafloor spreading, it's tearing me apart, divergent boundary, builds mountains. We hope to see you tomorrow so that we can get some fun labs done with you in class. The concern here is that seafloor spreading is tearing me apart. And if you remember that, it'll hopefully help you remember that you're at a divergent plate boundary.